Okay guys, so now we're going to talk about the distance between parallel lines. This is a little bit nicer because you're going to get the equations of the parallel lines. So there are two lines here, and I know that they're parallel because they have the same slope. They each have a slope of 2. And what I did was I graphed line L in red here, and I graphed line M. So you can name them anything you want. I'm just giving them different names so they're easier to determine, individually. And I'm naming the purple line here M, okay? And I just used rise over run to plot them. I plotted the y-intercept and then used rise over run. So you should remember that from algebra. Okay, so the idea is that I want to find the distance between two parallel lines. And of course, the shortest distance is going to be the perpendicular distance. So because I've already gotten the equations for both lines, I already know the slope of my perpendicular line. It's -1/2, right? It's the opposite or negative reciprocal of the slope of one of the lines. So here's what you do. You choose a line, okay? So I don't have my blue pen with me, this color blue. Let me see, maybe I do. I do. So what you do is you decide, which line you want to start with. And it's not even the line that you're starting with, it's the y-intercept. So for this line here, the y-intercept is 0, 1. And for this line here, the y-intercept is 0, -3. Okay? Oops, I'm out of focus. How come? Why am I out of focus here? Hang on 1 second. There we go. Okay, so anyway, what I did was I started with this one here first. So this is the line I'm using first, line M. Okay, you could use line L, it doesn't matter. I find the slope perpendicular to this line, which is -1/2, and I'm going to use the y-intercept from this line. And what I'm going to do is I'm going to use the point and the slope in point slope formula to find the equation of the line perpendicular. So I'm using this y-intercept 0, -3 right here. Okay, and if I draw a perpendicular up to the other line that I'm not using, this is a point on the perpendicular line. I know the slope of the perpendicular line, so therefore I can find the equation of the perpendicular line. So I have y minus a -3 gives you y plus 3 is equal to our slope times x minus 0. So cleaning up the right hand side, I get just -1/2 x, and if I subtract 3 from both sides, I get the line y equals to -1/2 x minus 3. Now you can call this y perpendicular if you want, or you can call it line P for perpendicular. Okay, so now you know that you have the equation of the perpendicular line. Okay, at that point, what you need to do, because remember, if this is perpendicular here, this is also perpendicular here. So now what I'm trying to do is find this point here at the foot of this perpendicular on the line that I haven't used. Okay, so I know this point, it's the point 0, -3. This point I have no idea what it is, so that's what I need to find so I can use the distance formula. So this is the same as the equation of a line and a point not on the line. Okay, we're sort of doing the same thing. Okay, so what I'm going to do now is I'm going to take the equation of the perpendicular line, which is here on the right hand side, and set it equal to the equation of the line I didn't use. Well, I started off using information from line M, so that one's done. So I'm going to set it equal to the other line, 2x plus 1. So that's what I did down here. Okay, and when I solve, I'm going to get the x coordinate of that missing point that I'm looking for on the foot of the perpendicular of the red line. So I got rid of fractions by multiplying every term, both sides, by 2. So I get 4x plus 2 is equal to -1x minus 6. And if I combine like terms, I add x to get 5x. I subtract 2 to get -8. So x is -8/5. Again, an ugly little fraction, but that's life with these. Okay. Now I need to find the y coordinate. So the easiest thing to do is to just substitute this x value into the equation for the perpendicular line, right, which was negative 1/2 x minus 3. So when I substitute that x value, I get a negative times a negative is going to give me a positive result. 1 times 8 is 8 in the numerator, and 2 times 5 is 10 in the denominator, minus 3. I have to combine those now to get, you know, an improper fraction. So again, you know, I have 8 over 10 minus 3 over 1. I can't subtract because the denominators are not the same. So if I multiply this fraction by 10 over 10, then what that's going to give me is 8 over 10 minus 30 over 10. Right? And now look, I'm going to have a common denominator of 10, and it's 8 minus 30. So that's 22. The bigger number is 30, and it's negative, so I have to assign the negative. And I can reduce that down. 2 goes into negative 22 negative 11 times, and 2 goes into 10 5. So the value for y is negative 11/5. Okay? So now what I have is this point that I found, negative 8/5, negative 11/5. That's on the red line, or yeah, on the red line L. Okay? And I'm going to use that along with the y-intercept that I used to begin with, 0, negative 3, and I'm going to plug that into the distance formula. Okay, so a little bit ugly here, but I have 0 minus a negative 8/5 becomes 0 plus 8/5, or just 8/5 squared. Negative 3 minus a negative 11/5 becomes negative 3 plus 11/5 squared. This I can't simplify anymore, but this I can. This is negative 15 plus 11, or negative 4, back over the common denominator. So now if I square this term, 8 squared is 64, 5 squared is 25, bring over the plus. Negative 4 squared is positive 16, over 5 squared is 25. Okay, and if I add the two fractions together, because I can, because the denominators are the same, 64 and 16 is 80 over 25. Rules of radicals say I can put the top in its own radical, or the numerator in its own radical, and the denominator in its own radical. And then I know that 16 times 5 is 80, so I'm writing out the factors here, and I know that the square root of 25 is 5. So 16 is a perfect square, so the square root of 16 is 4. That comes out of the house. 5's prime, so it stays in the house, in the radical, divided by 5. And if you use your calculator, the distance is about 1.8. So when I go back to this picture, the distance between this point and this point right here is about 1.8 units. Okay? Here's another one. So let's suppose y equals x plus 5 and y equals x minus 3. These two lines are parallel, and I know that the slope is 1, right? So if I wanted to graph them, I could just do a sketch real quick. The y-intercept here is 0, 5, and the y-intercept for this line is 0, negative 3. So 1, 2, 3, 4, 5, I plot the y-intercept. The slope is 1, rise over run equals 1 over 1, right? That's the slope. So I'm going to go up 1. So from the y-intercept, I'm going to go up 1 and over 1, plot the other point, and then connect them with a straight line. So I'll call this one line L in green. In blue, I'm going to plot this line. The y-intercept is at 0, negative 3, so it's here. The slope is still 1, so from here I'm going to rise up 1 and go over 1 and plot my other point. So I know that my, it's just a sketch. This is my line. I'm going to call it M, so I'm going to call this one M, right? And now the goal is to find the distance between the 2 points. So again, what line do you want to start with? I'm going to start with line M, this one here, right? And I know that this y-intercept is 0, negative 3, okay? And I'm going to draw a perpendicular line to line L. So, if the slope here is 1, then that means that the perpendicular slope has to be negative 1. I'm going to use this slope and this y-intercept to find the equation of the perpendicular line using point slope formula. Y minus a minus 3 is equal to negative 1 times x minus 0. That gives us y plus 3 is equal to negative 1 times x, or just negative x is how we usually write it. Now if I subtract 3 from both sides, I get y is equal to negative 1x minus 3. This is the equation of my perpendicular line. You can call it P for perpendicular if you want to. Now what am I going to do? Well, the steps that you should have in your notebook say that I take the equation of my perpendicular, and I set it equal to the equation of the line that I have not used yet. So that way I can find the x coordinate of this point right here. This is some x and some y. Okay, so there's not really anything to do here, so I'm going to combine terms. I'm going to subtract x from both sides. Negative 1x plus a negative 1x gives me negative 2x. If I add 3 to both sides, I'm going to have negative 2x is equal to 8. And if I divide both sides by negative 2, I get that x is negative 4. Oops, sorry. So the x coordinate of my point is negative 4. To find the y coordinate, pretty simple. I'm going to plug it right back into the perpendicular equation. So y is equal to negative 1 times negative 4 minus 3. You're going to be careful with the signs here. Y is equal to negative 1 times the negative 4 gives us a positive 4. Bring down the minus 3, and 4 minus 3 is 1. So this point here up on line L, xy, is actually the point negative 4, 1. I have to find the distance between this point and that point. Easy, right? The distance formula says, so let me put the points close so we can see them. Point negative 4, 1, and we've got the y-intercept 0, negative 3. So distance is equal to 0 minus a negative 4 squared, x2 minus x1, plus y2 minus y1, negative 3 minus 1 squared. That's equal, 0 minus a negative 4 is 0 plus 4, or just 4 squared. Negative 3 minus 1 is a negative 4 squared. That's going to give me 16 plus 16, and that's the square root of 32. Now I could have noticed that this is the same as 2 times 16. I can write this as 16 times 2. Rules of radicals say if I can write the radicand, the stuff inside, as a product, then I can put them in their own houses, right, or in their own radicals. The square root of 16 is 4. The square root of 2 is prime, or 2 is prime, so we leave it in the square root. So the distance between those 2 points is 4 root 2. And again, if you put that into your calculator, so you can get an idea of what that is. 4 square root of 2 is equal to about 5.7. Okay, so it's about, this is about approximately equal to 5.7 units. Capiche? That's it. All right, so try and do those practice problems on your on the worksheet that I assigned to you, and we'll go over any questions that you have on Friday. Have a good night. Okay, so now the fractions are gone. Now I can collect like terms. If I add 1 to both sides, I'm going to have 10x minus 6 is equal to 10. If I add 6 to both sides, 10x is equal to 16. So x is equal to 16 tenths, and I want to reduce that. 2 goes into 16 8 times, and 2 goes into 10 5 times. So x is 8 fifths. To find y, I'm going to substitute that either into the first equation or the second. Okay, whatever's easier. I think the first equation would be a little bit better, and which is here. So I'm going to use y is equal to 3 times 8/5 minus 2. That's 24/5 minus 2. 3 times 8 is 24 over the common denominator. Put that over 1 if you need to. Okay, and now I've got to combine these again. So I could multiply 2 over 1 by 5 over 5 to get the denominators to be the same. That's 24 over 5 minus 10 over 5, right? 2 times 5 is 10, 1 times 5 is 5. The denominators are the same, and so now that means that I can go ahead and add or subtract the numerators and put the same denominator, one denominator, right? 5. 24 minus 10 is 14, and I can't reduce that anymore. So the x-coordinate of the point at the foot of the perpendicular is 8/5, and the y-coordinate is 14/5. And now I can use this point in conjunction with point P, which was given to me at 1, 3, into the distance formula. So let's do that. So we have distance, and I'll write the points up here again so you can see them. 8/5, 14/5, and 1, 3. So they're not pretty numbers, but again, that's what we got to deal with. So remember, it's x1 minus x2 squared, so 1 minus 8/5 squared, plus y2 minus y1 squared. I've got to clean up these fractions in here. This is 5 minus 8, or negative 3/5 squared. Over here it's 15 minus 14, or 1/5 squared. Negative 3 squared is 9, 5 squared is 25, 1 squared is 1, 5 squared is 25. That gives me same denominator, 25. 9 plus 1 is 10. I can write these in their own radicals, root 10 over root 25. Root 10 is going to stay root 10, because if I factor that out, the only factors are 1 times 10 or 2 times 5, and there's no perfect square in any of those factors. However, we know that the square root of 25 is 5. So the distance between the 2 points, between this point here, which is 1, 3, and the foot of this perpendicular, which is 8/5, 14/5, is, what did I say it was? 10 square root of 10 over 5. Now if I put that into my calculator, I have the calculator there. If I do the square root of 10, divided by divided by 5, it's about 0.632. So this is a very tiny number, a very tiny distance, and you could even say that that's approximately equal to 0.632. Okay? Very tiny. That's how you find the distance between a line and a point not on the line. And you have practice on the worksheet I gave you today, like the first 4 problems, I think, are just finding the distance between them. Okay? The next video, I'm going to cover distance between parallel lines. Okay, so I'll post that as soon as it's done.